hit it? Nope. Nope, I didn't hit it. All right. Let's take a quick look at current events. What have we got here? Is this me? All right. Anything? I saw this on my phone. I didn't really understand what he was trying to say at all. Okay, interesting. Let's go to where I was yesterday. All right, so do I want to jump right into, let's see, what were the options for this one? It's called 2-bucket. Oh yeah, I wanted to jump right into the VLAN. Okay, so did I do the hello world? I think probably. Not closure. Is cool. Hey, how is it going? How is your Saturday? Okay, VLAN. Okay, so did this work? I think it did. So that was fine. So let's go to 2-bucket. Let's see what we get here. Okay. Let's see what's in our file. Alright, so the bucket ID is either 1 or 2. Fair enough. The solution has to have moves and a bucket ID in it and another bucket. Okay. So we figured out that we can check first. So if goal is greater than capacity 1 and goal is greater than capacity 2, then we don't have a solution. And so if we didn't have a solution, what were we supposed to say? I don't think I looked at the test in this one. Let's see what the test says. It was supposed to be an error message that said impossible. Okay, and so I saw something wherever I was looking at the VLAN stuff, and it said, are these my phone histories? Very nice. Well, now we see it. Okay. All right, so VLAN. There was something in here about returning the errors, right? It was something a little bit similar to how it is in Go, but not the same, I think. Okay, so error is maybe kind of a hard thing to search for here. That's not necessarily unexpected. Okay, so when returning, no. Warnings and declaration errors. We want error handling, right? Okay, let's see. Error handling. This one. Okay, so like this. So in this case, we will return error impossible. Let's see if that satisfied what it was asking for. So the exclamation here, so they have a bang on solution. Is that meaning that it could be an error? Let's see. So yeah, they put that here on the user. Result types use bang type. Okay, sure. Can we do var solution like in Go and then just return solution? Somehow I doubt it, but let's see what it says. Nope. So we can't use var like that. Let's look at what it said for variables. What if we want, so our declared and initialized, this is the only way. Okay, okay. Fine, fine. So solution. All right, can we run that? Okay, let's see. So we don't use a comma. Let's look at the struct. So they did X and Y. Do we always have to, you know, if we always have to do that, that's probably fine. So do you think it's saying we can just do an empty solution? Is that a possibility? Let's see. Yes. Okay, let me see where my music went. All right. So which one passed? Was it the one that I thought impossible? Okay, so that was great. That was all too easy. All right. Let's look at the run test again. All right, let's make another one pass. So we had an error. Okay, not possible, so not that one yet. Okay, so let's do this other sort of edge case type thing, which is, so if one, okay, so what gets passed in? A start bucket. Okay, so if, let's see here. Enum, huh? So on the enum, let's see where that is here. So we can do an int. Okay. So we'll say if, I feel like the hold on. Okay, so I'm gonna say if goal, no, if start bucket equals 1 and, okay, so I am gonna want parentheses for this. And capacity 1 equals goal, or start bucket equals 2 and capacity 2 equals goal. So, So here we are going to return a solution, but okay, yeah. So this shouldn't be too bad. So we'll return solution. Moves will be 1 in this case. Goal bucket will be start bucket. And other bucket, in this case, will be 0. Okay? And then we'll do if start bucket equals 1 and capacity 2 equals goal. Or I do appreciate the very similar syntax to Go. I actually appreciate that a lot. I think it's nice. Start bucket equals 2 and capacity 1 equals goal. Okay, so in this case, we'll have another solution. This time, the moves will be 2. The goal bucket will be not the start bucket. Do we have a ternary? We have an if expression. Okay, so goal bucket if start bucket equals 1. Two else 1. Okay. And other bucket will be, okay, so let me drop these down. So other bucket will be if start bucket equals 1, then capacity 1, else capacity 2. I think that should make one of the tests pass. Nope, not yet. Unexpected token. Yep, I did mess that up indeed. Unexpected EOF. Okay. So I got this. Return solution. Okay. Nope. Non-bool type void used as if condition. Start bucket equals 1. Huh, I don't know why that is. Non-bool type void used as if condition. Start bucket equals 1. Does it say that everywhere? So if num mod 2 double equals 0, is this something about the enum? Do we need to maybe, wait a minute. Match. Okay, so where do I have 1 here? So 1 is there. So this is bucket ID.1, I believe. And here likewise. Is that better? No. Oh no, 3 passed. Okay, so which ones did it say passed? 1 step using bucket. 3 passed. Okay, yeah, this is going along the right track then. So if I recall correctly, I think that actually covers all the edge cases, and then now I think we want to do the main case next. Format. Okay, so intro. Install from source. VLang command line code. Or you think they use prettier? I kind of hope they use prettier. Oh, tools. Okay, so it says V format. Excellent. Let's do it. V format 2 bucket. Yeah? Okay, we want -W. Same as Go format. That's fine. Okay, reformatted. All right, let's see if it looks better. Yes, yes, this looks nice. Okay, cool. So I don't have much syntax highlighting. I am gonna no, I'm just gonna see if I can get some syntax highlighting going real quick. So this is tools, V shader. Interesting, interesting. This sounds like a winner. I'm not gonna use that for this, that's for sure. VLang, Vim, highlighting, and LSP. Hit me with both if we can. All right, vAnalyzer. Oh, yeah, this sounds like a winner. So we can install like this. Wait a minute. vAnalyzer. I guess that's fine. VLang, vAnalyzer, Vim. I want to keep searching because so many times there is somebody who has made it so easy. Can we do it with plug? In this case, let's just do it the way they said here. I think it's still easy. So this probably just does it, right? Let's hit it. Yeah. Okay, so So we have the path to the binary here. So we want to add this to our path. So let's try that in our ZSH. Sure. And then we can source that. So we added that to our path, and then we want to specify the full path in our editor settings. Or do you think maybe it works already? No. In our editor settings, we want to do whatever it says here somewhere. Uh-oh, is this a separate one? I didn't want to spend much time on this. Let's try that. Sure, why not? I guess it's probably okay. So then, let's see, were there any hints here? This one looks okay. So now, usage. Okay. I don't recall whether I have those. Okay, so it says open any V file and execute lsp install server. Okay, let's try. I don't think that is ready to go. Okay, so we need both these. Vim lsp. Okay, we can do it like this. Cool. Okay, so let's try putting this plug in here. Okay, cool. So now plug install. Okay. And then I think that one's good to go. Then this second one. So this is the one we just got, right? Okay. And then we want this one as well. Okay, cool. Okay, great. So now it should be ready, I think. Install variable Verilog ls? No, it's not Verilog. Cancel. What the? It's not Verilog. Dang it. Okay, let me see again. So we did... Wait, what did it say? It said something. It said, please do lsp install server to enable language server variable Verilog. No, it's not variable Verilog of all things. No, it's a completely different V file. Ah! Okay, maybe we can fix it. Supported languages. Okay, variable Verilog. We want V analyzer and VLang VLS. Okay, so when we do this, instead of doing Verilog, we can just put the name, right? Probably. Let's just put the name. So we want vAnalyzer. Messages. Okay, one more try. Let's try VLang VLS. Okay, so LSP install server VLang VLS. VLang VLS, right? Okay, let's give it a shot. Darn. And messages say... Alright, I give up for now. If I come back to V at some later point, I'll maybe try again, but alright, it's fine. Alright. So, overall, I would say that this language seems very nice. So now at this point, let's initialize our solution. So let's, I guess, initialize it with moves 0. Goal bucket will be start bucket. And other bucket will be initialized at 0. Okay. Fine, fine. So I want a couple other variables here as well. So we're gonna have volume 1, which will be initialized to 0, and volume 2, which will be initialized to 0. Okay. So now we'll say for, and we're just going until... So this, we're going to go while volume 2 not equal goal. I meant to do 1 first. 1 not equal goal, and volume 2 not equal goal. All right. I don't know if it's the same as in Go. I wrote that as if it were the same as in Go. So let's see. For loop. Yep, it looks like it's like Go. So that... Oh, that's very nice. I like that they don't have to use that range keyword. Although it's not a big deal to use the range keyword in Go. But not having to use it is very nice. Very cool. So for in should be the most common form. All right. Map for. Okay, we could do that. Range for. Okay, cool. Awesome. Okay, so condition for is the one I just did. There's also bear for and C4. Amazing. So great. So great. I think I could really like this VLang. It seems very nice. Similar to Go, of course, but I do feel like they've made some little tweaks that I appreciate. Anyway, so let's go through this loop. So when we do a move, the first thing we're going to do is we're going to say solution moves plus equals 1. Okay? Because we're making a move. All right. Now, so we want to say, here's the thing, like, the question of which bucket is the start bucket is a little bit annoying, so let's fix that. So this part is already fine, I guess, so let's fix it after that. So I'm going to say capacity start is going to be set to if start bucket is bucket ID 1, then it will be capacity 1, else capacity 2. So we can stop messing with it's going to be really irritating. And then these are going to be volume start and volume other. And then this one will be capacity other if start bucket is bucket ID 2, then that will be capacity 2, else capacity 1. Okay? All right, cool. So volume, capacity start, capacity other, volume start, volume other. Okay, so then we're not going to look at volume 1. We're going to look at volume start, and we're going to look at volume other. All right, so we'll increment the moves. I have my paper here somewhere, right? Okay. So then if let me see here. I need to remind myself, I'm looking at my paper again for yesterday to remind myself what the moves should be. Okay. So we fill the start bucket. Okay, so if volume start equals capacity start and volume other equals 0, pour start into other, right? So now we'll say, so now this depends on like the volume. So we're going to say it depends on whether the other is larger or smaller than the start. So if capacity other is greater than volume start, so in this case, volume start minus equals equals 0, and volume other plus equals, and this has to happen first, plus equals volume start. I guess it doesn't have to because we could add the capacity. Okay, so that would be that case. Okay, so then else volume other will be set to capacity other, and volume start minus equals capacity other. I'm going to say volume other. It doesn't matter. Okay. So next case, I guess. Else if. All right, so if the other is full, then we dump it out, I believe. Okay, so else if volume other equals capacity other, dump out other. Okay. All right, next case. So the way I have it in this example, I never dump out the start bucket. Let me look at one of these other examples to see if I ever dump out the start bucket. The way I have it, I always pour the start bucket into the other. I don't dump it out. Let's see. All right. So I have pour start into other, I have dump out other, and then we have fill start. I never fill the other directly, I always fill the start. I believe, yeah. Okay, so, and I think that's like literally the only case. So here I'll say else fill start, and I'll say volume start equals capacity start. And that's it. Okay, so then when we exit the for loop, we then have to like process like which one ended up with the goal, right? So when we exit the for loop, it's because of this. All right, so now before doing that, we've got to check for loops. All right. So let's see where the map is. So maps. So do you think we use maps for sets the same as in Go? Because that's a little bit of a dumb thing in Go. Like it'd be nice if they just gave us a dedicated set. But let's see. So maps here. All right, I'm just gonna say that it's the same as in Go for now. Oh, and what about tuple? Oh, nothing here about tuple. Interesting. Oh, I was kind of looking for that. Let's do that. 0 start bucket 0. Here I'll leave it alone. Okay, so I guess I will define a struct for like struct bucket state volume start int volume other int, and so then we'll say scene states will be a map of bucket state to bucket state. There it is. Oh shoot. To empty struct. So then if through this process we come to a previously seen state, then we're going to early return. Okay, and so that's going to be return error impossible, and that is if well, let's first say bucket state is going to be a bucket state of that. Okay, so then we say if so when we get something out of a map, can it say okay the way we do in Go? I think that's different, right? Where'd my map go? Because here we don't just like return a tuple basically from the function. We return like an optional, right? So if a key is not found, a 0 value is returned by default. Oh. So is this what we want to do? I'm not sure. Well, yeah, sure. Let's see what happens. So I'll say if, and we can discard this because I'm not going to do anything with it. Okay, so if this, and we're going to say is scene states bucket state. Okay, let's try V formatting again. Stucked. Oh no. Oh no. I wanted my syntax highlighting to work. I might try it again, but I don't know. We might be getting close to finishing. All right. Only support string, integer. Oh, really? Oh, no. What? Oh, that's a disappointment. Okay, so what should we do then here? Darn. Was there something here about set? No. Hmm. Well, that seems like a ding against the language. It still seems cool, but it seems like a little bit of a ding, maybe. Okay, so yeah, how do we want to do a set? Okay, so vlang set membership. Uh, built-in. Hold on. Here we go. Ooh, yes. Okay, so where does this come from? Nope, I don't think that's it. Darn. Okay. Set ASN1. Okay, it's fine. I'm just gonna put them into, I guess, an array or whatever. I don't know if we have slices like in Go, do we? Let's just put them in an array or whatever, and we can just check it in linear time. Kinda dumb, but I just want to get it done, baby. Ah, you know what? That's not a good excuse. That's not a good excuse. So we use this for append. That's cool. Okay, so let's go back and redo a lot of this. All right, so the bucket state is still fine. We still want that probably. But we do not want a map at all, unfortunately. So scene states now is actually going to be an array. And then when we initialize an empty array, where do we put the type? What? Oh, can we wait? Okay. It can be struck. So, okay. Good, good, good. Okay, so it's an array of bucket state. Love it. Okay, so we don't want to do that. So now, do we have array methods? Because that'd be nice. Yeah, these look good. Ooh, find first with a predicate. Okay, yeah. Okay. So do we import? I don't know about importing yet. Is it import just like in Go? Does that seem like too much to hope for? Probably, because I don't have any LSP working. All right, so if arrays find first, scene states so for the state, should we like define an equals method on it? So like, so that would be function, and then it would take a B bucket state, and then the name would be equals, and takes B2 bucket state and returns bool, and then say return B volume start equals B2 volume start, and B volume other equals B2 volume other. I really want LSP. It'd be so nice. I think I'm going to go back and try again. Okay, so scene states, we're going to try passing a predicate. It is going to take a B bucket state. Okay. It's going to return a bool. Return B equals bucket state. Okay, let's see what it says. Import has been oh, okay, cool. Well, that's a helpful message. Thank you. Okay. Well, it formatted it. I guess that's a step in the right direction. Okay. So, in theory, we think this should prevent us from entering an infinite loop because there's probably only so many states that these buckets could have. We'll see, we'll see. But anyway, then now let's fill in what happens at the very end. So we're gonna say, so now we have to return which of them it was. So if volume start equals goal, okay, then we're going to return solution. I didn't end up using the solution at all, did I? Oh, I added one to the moves. That's the only place I used it? Okay, I don't like that. I'm just going to get rid of it. I'm going to say moves equals 0. Okay, so here, moves will be moves. Okay. Then what's the next part? The goal bucket. Goal bucket. And so that will be if start bucket is bucket ID, bucket ID 1. Then we return bucket ID 1, else bucket ID 2. Okay. And then the other one was other bucket. Okay, so we don't want this. So then we say else return solution. Moves will be moves. Goal bucket will be if start bucket equals bucket ID 1, then it is bucket ID 2, else bucket ID 1, and other bucket will be volume start. All right, let's see what the test says. Did anything pass? Nothing passed. So we've got an error. Let's see. Warning, unused variable bucket state. Okay, let's take a look at that first of all. Oh, yeah, I never added it. That's so dumb. But, you know, we are supposedly using it here, so that doesn't seem good. I think there's something else going on. But first of all, scene states add bucket state. Yep, that for sure needs to be added. Okay, is that any better? No. Okay, so it says moves is undefined. Okay, I guess I messed that up. Oh, yes, I did. I didn't use the walrus. Moves is immutable. Declare it with mute to make it mutable. Yeah, I should have thought of that, I guess. Okay. Undefined. So bucket state here is undefined. That's not good. So the array also has to be declared as mutable if we're going to append to it. Fair enough, fair enough. Okay, so we're down to this one. Okay, so we declared the bucket state, we thought, here, but then we couldn't use it here, so I guess it's not in scope. Joko Numi, hello buddy, you stream pretty cool, I love it, and I want to be a friend with a sick ideas for your channel. Chat me up on Discord, El Cavarina. Yeah, totally. Like, I have a Discord link there, but, you know, if you want me to add you, I guess, like, yeah, just let me know. It sounds fine to me, man. All right, so it's a state thing here, right? The buckets, or excuse me, I was looking at the word state. A scope thing. It's a scope thing, right? So I have a bucket state here. Sure, that's fine. And I set it to something. Okay. So then I said if, and then I put in a function here, but then I have a bucket state here. So is there something about like a global or something sort of similar to in Python? Let's see what it says here. By default, does not allow global variables. All right, fair enough, fair enough. So what do we what do we want to do? Okay, I just don't want to do that at all then. I'm gonna use a regular loop. So we'll say for b for, yeah, we can discard the index, b in scene states if b equals bucket state, return error impossible. Or passed. That's progress. Okay. Arrays imported but never used. Okay, let's get rid of it. Failed with error impossible. Okay, so that's messed up. But we did get one correct on one step. Yep, that was a special case. Yeah, these are special cases. Was this also a special case? Yep. So this one came out okay. So none of the regular ones that follow the happy path or whatever worked yet. And they all returned impossible. So that's not what we wanted at all. Okay. So right here, so for b in scene states, if b equals bucket state, return error impossible. And then we are supposed to append the scene states to the bucket state. Okay, so print. Okay, so let's try printing line. Uh-oh. Something very unexpected may be going on. Let's see what it looks like. Will it show the printout? Okay. So we saw 6-0. Oh, and this is one I did in my notebook, right? I think so. Yep, I definitely did it wrong. I don't have the logic correct whatsoever. All I'm seeing is 6s and 0s. That's really bad. Wheel. So we have the 3-0 and nothing. Okay. Is this one that's in my book? I believe so. Okay, then we do this, and we have that in the previous states. So then we went to 0, 0, which is not where I was supposed to go at all. I was supposed to fill the first instead of dumping. So yeah, I've got the logic wrong. I dumped the other. No, let me see. Okay, so let me just change the print. So let's not print that one for now. Okay, so in this very first one, we go 3, 0. Okay, as expected. So then we pour it into the other. Okay, so far so good. Okay, so then I dumped the other too soon, which is exactly what I wrote in the code, of course. But no, at this point we were supposed to fill the start, and I left that step out completely, so let's add it. So filling the start is something that we're supposed to do. So dumping out the other is something I did when I wasn't supposed to. Oh, wait. Let's see. So I filled the start, poured it into the other. Then I was supposed to fill the start again, and I dumped out the other. Wait. Okay. So we fill start, and that is what we see. Pour start into other, that is what we see. Yeah, dump out other, I was expecting that to not happen yet. Okay, so what's the deal? Okay, so this doesn't have to only happen when volume of other is 0. It could be any time that volume of other is less than capacity other. I don't think that's the problem, though. What's it there? Okay, so I guess I'll just put them into an array. Okay, so in this first example, no, this is not correct. Okay, let's go back. So that's clearly the problem. So capacity other, if start bucket, wait. Okay, well that was very wrong. Weirdo mistake, but okay. So still 4 passed, so let's look at just this first one. Okay, so we went to fill the start. Okay, so far so good. Pour the start into the other. Yep, that's what I have on my paper. Fill the start. That is also what I have on my paper. Cool. Pour start into other. Nope. It went up to 6. It was not supposed to be 0.6. It was supposed to be 1.5. And I coded something for that, but clearly I didn't do it right. Okay, so if capacity other is greater than volume start. Okay, so yeah, that's our problem. If capacity other minus volume other. And so then here it is okay, a lot of goofy mistakes here. Wait, did more pass? No, still just 4. A lot of goofy mistakes. Okay, so 3-0, that's correct. Oh no, this ended up 3-5. Interesting. So I said volume start minus equals. Oh, this needed to be before, right? Yeah, of course. Okay. So another one passed, I guess. Was it this one? So we went, yeah, looks like it was, I guess. So we went 3-0, 0-3, 3-3, 1-5, and then we were done. Okay, next example. We went 5-0, okay. 2-3, yep. 2-0, yep. Then we went to 5-0, so that was not it. We were supposed to dump at this point. Or, no, we were supposed to pour start into other at that point. Yeah, not dump, sorry. We were supposed to pour start into other. And that was... So here, I think it is actually greater than 0. Is that it? Maybe. Okay, so they all passed. Okay, so that was the last logical error. Oh my goodness gracious. Okay, let me get rid of those print lines then, or actually just comment them out. Okay, let's format. I'm gonna submit and move on. I feel okay about that. Kinda okay. I would say, let's try and review. So I would say my biggest disappointment there, one big disappointment is that I didn't get the LSP to work. I would have liked it to. And of course, like, it's pretty lame that I made some pretty lame logic errors. But whatever. I've felt worse about some others in the past, that's for sure. Okay. Let's see if it's accepted on the site. I'll just close some of these out. Oh, it did list this one as a medium, so that's interesting. I can kind of see it. It's pretty simple, but I did end up with kind of a lot of code in this one. I guess it would be good to refactor. There's no way that this much code is actually required. Oh, and another thing like this, I'd like to refactor this to use some kind of a map, basically. All right, are we accepted? So I'm a little surprised to see it as a medium, but like, given how much I have in here and the kind of logic errors I have, maybe it makes sense. But I thought the problem was more just my own, like, mistakes, plus just not being familiar with the language, of course. But either way, let's go to the next one. So I skipped over the Elm version of 2Bucket. Oh, did I not mark it as complete? And I'm not going to go back to the Elm version right now. Do that later. Let's check it out in Crystal. Does that seem like a good call? What time is it? I actually think I need a little bit of a break. Just a wee bit. Okay, so let me think. I think it'd be nice in Elm. There's still so many here. I feel like I want to do a fresh one that I haven't looked at before. Unison? Oh, you know what, actually? So, Reason ML, that one I really stumbled on. Is there another Reason ML problem that I could take a look at instead? I think that's actually the only one. Oh, there's a space in there. Okay. Yeah, that's the only Reason ML. Don't really want to go back to that one. I feel a little slow tonight, so I don't know how many more I'm going to finish. Ideally, I should finish 2 or 3 more. I mean, yeah, especially considering it's still pretty early, but I felt way more energized yesterday than I do today. So, I must say, one other thing I had considered was that to maybe speed up, it might make sense for me to pick ones that are in similar families. So what that might look at would be like, okay, so here's Elm, and then if I were to do the Elm, then I would skip to one that is a language that's somewhat similar to Elm. I might count Elixir as somewhat similar to Elm. They're functional programming languages. I think Haskell is more similar to Elm than Elixir is, but I don't see Haskell here. So maybe that's what I'll do. Maybe I'll try to just stick with functional programming languages to get into a little bit of a functional programming language mindset. So what that would look like would be to start with this Haskell one, and then go to this Erlang one, probably, and then Elm here, and knock out all the remaining functional programming language problems. I don't know what Unison is. I actually just wanted to look at the Unison blurb. Oh, it's gonna take me to straight there? Okay. That's fine. Let's give the tooling a shot then, I guess. Okay, let's see what we've got. Can we do that? Let's see if we have any luck. I just wanted it to tell me what Unison is. Here, let's just look it up on Wiki. Unison. Descended from icon? Uh-oh. Well, we can already see it does not say it is functional at all, right? So that would not be on the list. Since I already just started, I will probably at least do the hello world. Okay, so install Unison language. Okay. Sounds fine. And then can we do this? Why is there a dot there? Have I tried that already? Unison Codebase Manager executable. Let's go back to the hello world. Okay, so let's do this. I did it already? Why? How did this happen? Yeah, deja vu. Okay. How do we run the test? Okay, so make your changes, save. We're going to use UCM commands. Okay, this doesn't sound like something I've done already. Have I seen this already? I do not remember. Okay, so welcome to Unison. Okay, so we'll try the command that it said. Add. There's nothing for me to add right now. Update. Okay, okay, sure. And then okay, so load hello world, and the hello world was called what? It just hello test you. I couldn't figure out what test expect refers to here. I don't know. Okay, so here's what's in here. Use base text, hello, hello. Okay. So UCM, we want to go projects, scratch, okay, sure. Load hello you. Couldn't resolve any of these symbols text? Okay. I think something is missing for sure. So text, no matches here. Unison history. Okay, so it said could not resolve symbol text. I don't know about this. Did I miss something in the help? I think I did, right? So we start off by saying help. Make your changes, save. If the file type checks, run the add. Okay, so UCM add hello you. Nothing for me to add right now. Load hello you. Couldn't resolve any of these symbols. So what should I do? Can I get rid of the type annotation? Let's see. So it says use base text, right? Okay, so unison use base text. That's trying to import it, right? So text is here. It's a primitive type, sure. Not sure this is going to work well for me. Could not resolve any of these symbols. Hello text. Symbol text. Suggestions no matches. It says it's a built-in, provided by the runtime. Do we have a REPL? Okay. Uh-oh. Oh no. Yep, I don't think this is right. Looks like I'm missing something. Release 0.5.28. Huh. Okay. So, okay. So we didn't do that. So run UCM to initialize a unison code base. Okay, so can we do UCM to get started, just run unison. Okay. No. Okay, so we should create the code base, right? Like they said here. Right? Create code base. No, code base create, excuse me. Okay. And we'll go all right. Okay, unison. What are we doing? Compressing objects. Oh my goodness. Okay. So that's fine. All right, so what is this part? I mean, it sounds like it should be so straightforward, right? Okay, anything else? Okay. Well, hey, you know what? It looks a little nicer. Use base text. I don't think it's working. Yeah, they've got that dot there. What the heck? Okay. Huh. Okay, let's try it. Okay. So I think we want to like add a library to the project. Hmm. I don't know. I don't know. So yeah, it didn't work before this point. So we didn't create the project, right? So ls libbase, nothing to show. Okay, that's no surprise. So let's do project create quick start. Oh, yep. Wheel, that seemed totally straightforward, and I was just being dumb or stubborn or both. Now, the exorcism page warned this might take a while. I'm going to take 5 minutes. I'm going to take my 5-minute little break now. All right, I'll be right back. It's done. Okay. Oh, man. Okay. Uh-oh. Okay, so now let's look at the help again. Okay, well, there we go. That was confusing in a way that was actually a bit similar to Faro Smalltalk, but much, much easier. Faro Smalltalk was a real head scratcher. So this one's okay. Let's go ahead and submit that. So I'm actually kind of excited now to actually maybe try a problem in the Unison programming language. However, I don't know if I'm going to do that yet. I feel like chilling and taking it easy to some extent. Okay, so I'm going to step outside, actually. It's going to be Haskell food chain, followed by Erlang bank account, then Elm 2 bucket, then it's going to be Elixir phone number. Honestly, Prolog could almost fit. No, it couldn't. Prolog is almost sort of in the same super family, but no, it's not in the same family as these functional languages. Okay, so then we would go over, I don't know what Ren is actually. I'll skip it. Then another Erlang. Pure script. Pure script will be one. Another JQ right here. Oh, interesting. Then Gleam. And then Reason ML. Hopefully it'll, like when I'm in the functional programming world, hopefully it'll make sense. I'll skip over Lisp flavored Erlang and do that with other Lisps. Then we'll do Haskell. Actually, I'm not seeing that many Lisps here. Have I already done like a lot of the Lisps that there are? Maybe so. Interesting. I enjoyed working with the Lisps. I don't know what ballerina is. I'll just save it. Okay, so I'll skip this one. Haskell will do. Pure script will do. OCaml will do. I don't know, yeah, what ballerina is, so I'll skip it. Scheme, okay, so Scheme will go with Lisp flavored Erlang in a different section. And Racket will go with those as well. F# will go with the functional program. Oh, here's a common Lisp. Okay, so good. I was like, where are all the Lisps? There are a bunch here. But yeah, so we'll do F sharp after OCaml. So yeah, it'll be Reason ML, Haskell, Pure Script, OCaml, F sharp, OCaml again here. I don't really count Scala among the functional languages myself. Maybe I should, but I don't really think I do. Anyway, so that being said, let me come back in 5 minutes after I step outside for a second. All right, all right, all right. It's winter time or whatever. All right. So we were supposed to jump over to this one, Haskell food chain. Let's try it. Oh no, this one again? All right, well, you know what? Let's knock it out. Maybe it won't be so bad the second time. Did I not copy it? Okay. This might be a little crazy. I'm not sure what to expect. All right. So we know we've got all these crazy song lyrics or whatever, right? Okay. Test suite test passed? How so? Okay. Hmm. That's weird. Let's check the README. So it's an exercise about code refactoring. Okay. All right. So let's do what are our Haskell comments even like? So we'll say, so what are some ideas? So swallowing a chain of animals. So if we have a list is going to be a list of Haskell list. So it's string lacks an accompanying binding. Okay, so chain equals first rest okay, so but each one, so we have to have the bird, so if we're looking, we have to have the dog here, and the cat twice, and then the bird twice. Okay, let me review my other Haskell. I have acronym. Acronym is the only other one. All right, let's review it. This one was a pretty large file, right? Okay. So text returns text. Okay, so then I used if then else pretty extensively in this one, and that's probably good. I used it all over the place. Yeah, it was if then else city. Which is sort of ugly. I'm pretty sure it looks better if you use more of a matching syntax, but I think for now I'm gonna say I'm gonna just use if then else all over the place. Just like I did in the other one. So and there were no lists in this one. That's kind of unfortunate. So I believe Elm is pretty close to Haskell. So if we do if we look at some of the elms, let's look at each of the elms in turn. So I didn't do 2-bucket yet, but I do have it here, so it would be good to do that one. Let's look at the run length encoding. I think that one ended up turning out kind of nice. Okay, so here Yep, it definitely, the syntax definitely resembles Haskell, at least superficially. I used a lot of these pipes, which I didn't use in Haskell. So I don't know if those are any different. I did not use any if then else in this one. Oh wait, yes I did it right here. If then else. Okay, cool, cool. And if then else here as well. Oh, you know what? I don't like that I put the then on the same line as the if here, which I didn't do anywhere in the Haskell. The other Haskell one, let's see. No, there was only the one Haskell one. I don't know. I feel like I want to go do the Elm 2 bucket now. Actually, yeah, I do feel like that. I gotta just stick with something. I still have 2 hours, so let me try and finish. If I finish 2 more problems tonight, I will be on track, basically. So am I gonna go to the Elm 2 bucket? Because I downloaded it already with the intent to do it, and then I didn't do it yet. Okay, so here it is. So it looks a lot like what we had in the V thing. I have a bucket number and a state. Okay, okay. So this is going to be recursive, I'm thinking. I think that would only make sense. But I don't think this is going to be the recursive one. I think we're going to have another one, which is going to be like for what were the actions that we took? It was basically like pour, fill, a dump. Okay, I'm going to call it pour, fill, a dump. So they've done it all curried, I guess, and that's probably fine. So it'll take an int, a second int, a third int. It will not take a bucket number, I don't think. So we need a couple more ints. We don't need a bucket number. We do need a set. Let's see. So this is going to be a set of int. So then pour, fill, dump will be defined where we have volume 1, volume 1 and cap 1. Let's call it A. Volume A, cap A. Volume B, cap B. We do need the goal for sure. And then the set is going to be scene states. Okay, so then we need another int here for moves. Okay, so then we'll put the equals. Implement recursive function. Okay, cannot find a set type, so we probably have to put an import for that. Let's see, it says it's a package core latest set. It says it could be a tuple or whatever. I don't know why I said or whatever. It says it could be a tuple. Cannot find a set type. Yeah, I'm pretty sure we have to import something. So what did we import in here? I'm pretty sure we would have because we used regex. It was just import regex. Okay. So should we just import set? Is that better? Cannot find a set type. Okay, no good. It says import set exposing set. Oh, okay. Maybe some parentheses are missing. Let's see. 2, 4. One, 2, 3, 4, 5, 6. 1, 2, 3, 4. Oh. Let's see. Maybe some. What does that say? Can accept 6 definition. So I did miscount. How silly. One, 2, 3, 4, 5, 6. Oh, that's the return. Oh, my bad. Oh, so what does it return? So moves should actually be returned, I guess. So moves does not belong. Success compiled one module, sure. Okay, so now the edge cases we want to put in here are going to be if, then, else. So it's going to be if goal greater than bucket 1 size and goal greater than bucket 2 size. Then we say error impossible. And then did we use error in one of these others? Not in this one. Did we use it in allergies? I don't think I used it in any of them. Oh yeah, it's error invalid input. Okay, okay. So it's not like this. It is error. Says it should be maybe state. Oh, so maybe is not a result. So what is maybe then? So a result is error or okay. Let's look at the maybe. Maybe in Elm. Okay, so I guess if it's maybe, then we have to do nothing. Oh, darn. Oh, darn. Okay, so then we would look for another case, right? So that would be nothing. Okay, so then this one is actually a maybe int as well, because it could be nothing out of here. Okay, so if start bucket equals um, 1 and bucket 1 size equals goal, or start bucket equals 2 and bucket well-defined regulation says cheap viewers on viewers edge rue. Good to know about it, baby. Bucket 2 size equals goal. Okay. Then state moves 1. Oh shoot. Okay, so the way the state is actually different this time. I liked the way it was before, I think. Darn. Okay, so moves equals 1. Okay, so we put just. So we'll put just state moves equals 1. Okay, so this doesn't work. I guess we'll just have to check each of them. Okay, so moves equals 1. Bucket 1 equals goal. Bucket 2 equals 0. Okay. And then if else in Elm. So the if expression, we can have like else if, right? Or is it elif or anything like that? Yeah, else if. Okay. So this should really be like this. Else if okay, so then else if start bucket equals 2 and bucket 2 size equals goal. Then just state moves equals 1, bucket 1 equals 0, bucket 2 equals goal, right? Okay, else if start bucket equals 1 and bucket 2 size equals goal. Then just state moves equals 2, bucket 1 equals, and then, so in this case, bucket 1 ends up at bucket 1 size, right? Okay, so then, let's see, the just, so we pipe here, right? No? Yes? No? Something is off? Uh-oh. Type alias state moves bucket 1, bucket 2. Darn, I thought I'd be okay. Maybe this is not needed. Ah, okay. And this is not needed. Okay, cool. Okay, so then we need to fill something in for the else here. Let's get rid of that. Okay, so now we'll just do pour. Oh, shoot. So pour fill dump, I have it coming back with a maybe int, but I guess that's no good. It should be a maybe state. So then we'll do pour fill dump, and then we'll put in the needful here. And that is going to be volume A, which starts at 0, capacity A, which starts at let's see, if, then, else. Okay, so I think let's just put the if here. If start bucket equals 1, then, so then we pour fill dump. So it's going to be 0, it's going to be bucket 1 size, it's going to be 0, it's going to be bucket 2 size, it's going to be goal, right? And scene state is going to be nothing. Oh, it's going to be a set with nothing. So where's the thing about the set? Set empty. Yeah, I think so. Okay, so then else it will be pour fill dump 0 bucket 2 size 0 bucket 1 size goal set empty. Okay, so I believe that completes the measure. So we kind of covered these common, basically, edge cases here. And now it's the recursive part. So here it's nice that some matching can totally be done. So I'm gonna review like what was in the other file. Just I think it makes it a little easier on me. Even though I do also think that it's kind of dumb. Okay, so I put all that in there. Then what were the Elm comments again? Same as Haskell, right? So we go like this. Control V. All right, so which of this information is going to help? Probably not any of that. Do we need an equals for that? I don't think so. Okay, so then did we cover this situation if goal greater? That was the first thing we covered here, right? Okay, makes sense. Okay, so then what about this? Okay, so we covered that. Okay. We figured this out. Okay, so now, so the moves are going to be part of the state, right? Okay, so we've got those there. So the trouble is, I think we're going to need to actually pass a state in. All right, that's fine. We can pass a state in. I think we do need it. So this is going to be state. I'll just call it. And then when we pass that in, it is going to be moves equals 0, bucket 1 equals 0, bucket 2. Shoot. So no, that's not the way I want it at all. I definitely think it's dumb that I haven't thought of like the real or better way to deal with these bucket numbers 1 and 2. It's just, it seems like a really odd like quirk. Oh man, there's a lot there. So I guess the moves have to be passed in. Which I think is what I did before, and I just was like undecided. So we don't want this. Okay. So, all right, so we've got moves, we've got volume, we've got a set for scene states. Okay, so everything initialized, I guess. All right, so we're gonna say if vol A equals goal, right? Then, so then at this point, we actually do return. This is a base case. If volume A is the goal, then we are going to do... We can't pass back the state because I don't know which one's bucket 1 and which one's bucket 2. That's the trouble. So I guess I'll just pass in the start bucket and figure it out here. I don't know. Okay, so we'll pass a bucket number. Seems like too much. It really does. Okay, so if that's the goal, so now we pass back the state. So that's going to be just moves equals moves. So if start bucket is 1, then bucket 1 will be volume A. Okay. So far, so good. I'm taking a lot of time on this. I at least have a sense of confidence that I'll finish this one tonight. But beyond that, I don't know. All right, so I've put nothing here as a placeholder. Okay. So let's put else if volume B equals goal. All right. Then just moves equals moves. Bucket 1 equals if start bucket equals 1. Then vol B else vol A. No, hold on. It's the same thing either way, right? So that actually is kind of nice. Let me scooch these. Okay, so we don't want this as the else if. So here we want to check the set. So this is going to be else if, and then we'll check if something is in there. Member. Determine if a value is in a set. So we'll do set.member. And we'll say So then we'll pass in this tuple, which is going to be volume A, volume B, and then its scene states. So then here we really do impossible to refresh. Okay. Let's see what that gives us from what I've got so far. Okay, it says it compiled. What's test say? Okay, so we tried to run something. And then let me take a look at the tests. Okay, so we do have skip in several places. So let's, wherever we see skip, let's substitute. So I've got comma, space, skip, space, like this. And we'll change it to comma, dash, dash, skip. So we'll comment it out everywhere, right? Okay, that's better. Okay, so let's see what we passed. Or does it show what we passed? I think this is okay. So far, so good. All right, so now, okay, let's close this and do, it says LSP, oh, Elm language server. Well, I'll give it a shot. I think it's already okay, but I mean, I don't know. I don't think it hurts anything. I hope it doesn't. All right. So this is where the real action is supposed to happen. All right, so let's get rid of the placeholder. So this is where the recursive call is going to be found. So, whoops. I didn't hit something I didn't want, did I? I think I'm okay. So I'm going to say for fill a dump. No, this is where, let me put the placeholder back. What's the warning? Oh, that they're not used, unused pattern variable cap B. Okay, well, we'll use it, we'll use it. Okay, so we know moves will have to be plus equals 1. Let's get rid of this. Okay, so it's going to be else if and it's going to be cap B minus vol B greater than vol A. Then, okay, so now we'll have the inner if, so it's going to be if cap I think I did that really wrong. The one I wrote already is the inner if. This one should be vol A greater than 0 and vol B less than cap B. Okay. I don't like the red, honestly. Just saying parsing error. And give me a break, I'm in the middle of it. Okay, so we're gonna say greater than vol A here, then else. So in the then, we are gonna say pour fill dump. And now, let's see. Vol A becomes vol A subtract cap B minus vol B. Okay, cap A does not change. Vol B becomes cap B. And then cap B does not change. And then goal does not change. Now we have to add the states to seam states. Set insert. And that will be vol A, vol B, seam states. Okay, then this will be moves plus 1, and start bucket does not change. Okay. Yeah, I don't like that red. Okay, so did I miss a... no, that looks right. Oh, did I miss it here? Yeah, here. All right, so then else, we're gonna go pour fill dump. And then in this case, volume A will... Wait a minute, wait a minute. This is the one that goes here. I got lost. So this is pour fill dump. Volume A, in this case, becomes 0. Cap A does not change. Volume B becomes vol B plus vol A. Cap B does not change. Goal does not change. We do the same thing here with the insert. We increment the moves. Okay, cool. Honestly, in that LSP install, it has messed it up for me. I liked it better the way it was before. We can do... Hold on. We can do LSP server uninstall, right? I think I saw that. Was it here? Yeah, okay. LSP uninstall server. That was Elm, which is here, Elm. Okay. I think I'll be happier without that. Just wasn't working well for me. All right, so we did this part. I guess, should I delete this section now that I've done it? Probably. Don't need to worry about that. We'll do it each time. Hold on, let me bring this back. So this was if volume A greater than 0. Okay. So now there's going to be another else if here. This is going to be vol B equals cap B. All right, so then we'll say then. And then here, we're going to say for fill dump. Let me put some notes in here. So what did we do in this case? Poured all of A into B. Poured as much of A into B as would fit. Okay, so then here, while A is unchanged, cap A does not change. Here we put 0. So the note will say dumped out B. Okay, so then here, cap B does not change. Scroll up a little here. Okay, so then it's goal, which does not change. Syntactic, it's looking really super repetitious and very wet, write everything 2 or 3 or 10 times. But, I don't know. This would be a really good one to refactor after it's done. Okay, so then this last case, oh, this is the last case, so we don't need this. We don't need the placeholder. We don't need nothing. We just need to pour, fill, dump. So in this case, we do cap A, we're filling it. Cap A does not change. We'll leave this alone. Cap B does not change, goal does not change. We'll insert again. Increment moves. Start bucket does not change. Yeah, that should be the end of it, actually. So let me delete all these other notes. Okay. All right. Let's see the test. Passed. Let's submit it. I'm going to move on. Like I say, that would be a really good one to refactor because, man, not very readable, extremely repetitious, just generally quite ugly code in my opinion. But I do want to move on. So here's how it came out. Oh, and I didn't even put a note here. So this is filling A. But yeah, I mean, All right, not too shabby. So yeah, it badly needs a refactor, but I'm not going to do it now. I want to move on. So, which one do I want to move on to? I kind of hate food chain, I think, to be quite honest. Okay, we did this one. Let me mark it as complete. I think food chain is my least favorite, easily my least favorite of the 48 and 24 exercises I've done so far. And that's not fair. I don't think there's anything objectively wrong with it as an exercise. I just personally really don't like it. So I'm not going to do that. I think bank account Erlang, that seems like it'd be a good one to do. Or close out 2-bucket. Going by what time it is, I feel like closing out 2-bucket is probably the way to go. And then if this doesn't take super long, I might try to finish one more quick one after this, but we'll see. So I think Crystal as a language is probably not too far off from V. I don't know. I haven't looked at Crystal in a while now, so I don't think I really recall much of what I have seen. So there were 3 in here. There was Hello World. Let's look at the Hello World. Source. So the Hello World looked like this. We have class Hello World, def hello, Hello World, end. I'm happy with that. So it does look Ruby-ish, and I think that's the intention, so that's cool. I always thought Nim was supposed to look Python-ish, but I think that was a misconception. Does it even say Python? Straddles Pascal and Python. So it does sort of say it. The syntax of Nim. Okay, yeah, it says it right there. But when I looked at Nim stuff, I didn't really see it very much. But this, yeah, this resembles Ruby. All right, let's look at the protein translation, which is the only other one. So here's what I have. I have an at table. All right, that seems sensible. It's a small subset of the 20 amino acids, but that's fine, I guess. Just doing it as an example. All right, so then we def. Okay, so module wait. Def self.proteins. Okay, I'm not quite sure why it's self dot, but okay. So it takes a strand. We have a type annotation here and here. These look very sensible. If and, very nice. Yep, this seems fine. I think that I might like my solution in this one the best out of the 3, but let's see. Which is good, because it's, I mean, the 3rd one. So, having done it twice already, I think it'd be nice if this turned out to be the best of the 3. So let's see what's in the source file. Module 2-bucket. So the enum is here again. Yeah, it's fine, I guess. We have a self.measure. Write your code for the 2-bucket exercise in this file. Sure. Yeah. Seems fine, I guess. So I was thinking I might try copying the V code, but now I'm thinking I want to actually try copying the Elm code. Let's copy that into here, and then let's try editing it. Okay, so here's module 2-bucket. Great. And then ends here. And then the rest of this is the Elm code. So let's see. Crystal comments. Comments. So they start with a hash. Okay. So let's put a hash in here, I guess. So yeah, I guess I did the crystal before without like any syntax highlighting or anything. Let's see if I can get it going. Crystal syntax highlighting. Vim crystal. It's okay. Let's see. Copy autoload into your Vim, or use Vim plug. Okay, so I've usually been copy pasting when I use Vim plug, but we just have to put Vim crystal / Vim crystal, right? That's all we put, I would think. So let's see what happens when we do it. So I have all these plugs, okay. So let's do a plug for this. And let's see if it works. Okay. Oh, yes, this is much nicer. Hooray, my comment is colored a different color. That's all I wanted. All right, so now here, so in the measure, I had like some checks for like edge cases or whatever. So let's try putting those in here. So if goal greater than, wait a minute. So when we put in bucket 1 here, that's the capacity, right? So goal greater than bucket 1 and goal greater than bucket 2. Okay, cool. So do we put then or we put end? Let me look at it here. Crystal if statement. Yes, now we're getting into the basics. SAP? I don't think it's SAP. I think it's this. Okay, easy peasy. So here we wanted an error. So what kind of error are they looking for in the test? So it was not possible, so we wanted to raise argument error. Was it argument error? Apparently it's argument error. Okay. Raise argument error. So do I have to pass like the error message there? I think I did in the other one. No, it wasn't this. It was, what was it? Protein. Raise argument error dot new is what it was before. That would make sense. Let's do that. Okay, that's what I'll say. All right, so that covers that one. So then we'll say, oh, and what about the else? Where's the else? So if else. Yeah, okay. So let's say an else. Else if, oh, they mash it together. Okay. Else if, all right, so the next one is start bucket equals 1 and bucket 1 equals goal. Okay, cool. So in this case, we return the result. So that's going to be result new, I think. And we do actually, let's look at what it says. Crystal struct initialization. So here's a struct. and they just said counter.new. Okay, so it'll be result.new, and it will be 1, and let's see, other bucket and goal bucket. Let me see what it says in the spec. So other bucket 5. Okay. So it's more like it was in the VLAN. That's fine. All right. So that means other bucket in this case will have to be 0, and the goal bucket will have to be... Okay. Next. Else if... so here start bucket equals 2, and bucket... What did I say? Okay, so start bucket equals 1. Okay. And bucket 2 equals goal. Result.new, and so it's 1 to 0, but this time it's 2. All right. Else if start bucket equals 1, and bucket 2 equals goal. So here we'll do result.new, 2 moves this time. The other bucket is going to be bucket 1, I believe. Bucket 1, and no, 2. Good. Okay. Else if start bucket equals 2 and bucket 1 equals goal. Result new, and so this time 2 moves, bucket 2. Okay. So let's start deleting these as they're getting done. Okay. So then this is going to be else if start bucket equals 1. Then here, call the recursive helper, and then else. Call the recursive helper. All right, so then that's end. Okay, so now as far as the recursive helper goes, def self dot for fill dump. Okay, and it's gonna take volume A, u int 32. Sure. Cap A, u int 32. Vol B. I said I was supposed to refactor that crystal, but I'm basically reproducing the same sort of nonsense. So technically, like, if it says module to bucket, and then these are like self. So can I like put like properties somewhere? so that I don't have to keep passing these all the time, because several of them never change, so they don't need to be recursively passed. So can we have like a global or something within a module? We can have a class. Can we have a static or something? Um, this crystal reports diagrammatic. We want to look at, okay, so there's local variables, but I want like a field. Literals, types and methods, modules. I don't think I need that information. Something like a closure would totally help. Should I use a closure? No, I don't think that's quite it. Everything is an object. Okay, well, let's just try putting something up here. Okay, let's try doing it this way. So I'm going to say def cap A at cap A end. So that's one of them. Def cap B at cap B end. Def goal at goal end. Start bucket should never change. Def start bucket at start bucket. And okay, so if I have those four, I think that covers it. So if we go down to what my Elm code was like, we always had cap A, cap B. We always had goal. And we always had start bucket. Yeah, okay. So I'll be a lot happier if we can just use those. So I am not going to pass that in here. It's just going to be vol B. And then it is going to be the set. Okay, so that's going to be called scene states, right? And the type is set. And the tuple literal is like this. Okay, so it's going to be set tuple u int 32 u int 32. That's what I believe I want. All right, so that's scene states. And then the last one is moves. Okay. All right, so we'll put the first base case. So if volume A equals self goal, or so at this point, I think I want this as a separate if start bucket equals 1. And get rid of this. And then here, I want to say self dot goal equals goal, and self dot start bucket equals start bucket. But here, set cap A and cap set cap A and cap A the other way. Okay, but let me come back to that. Or volume B equals self goal. Okay. So here we want to say that we return what we want to return, right? And so that's going to be result new. We're going to put moves, and then we have to put which bucket. So in the if, so is the if an expression? It is, right? I think so. So here I would say, no, I don't think I can use it that way. Let's look at ternary if. Oh, okay, yeah, this is nice. Let's just use the typical, regular, nice ternary if. So this will be self dot start bucket equals 1. And then I hope that's okay. I guess I don't know why these don't have type annotations on them. Maybe it's fine. All right. So if it's 1, then this will become what? So in this case, so start bucket is always supposed to be volume A. Okay, so that's not what we want. We want I think I just want another if in here. So if self start bucket is 1, then it will be result.new moves. So then the other bucket is going to be vol B, right? No. Ugh, I hate it. So it's vol A equals self dot goal ternary. So if it is, then we put vol B, else vol A. And then here we put vol A equals self dot goal. So if so, then we want 1, else 2. Okay, so then else result new moves vol A equals self dot goal. Okay. Okay, so end that one. All right, so that's our first base case. Oh man, I think I liked it better the other way. It's just because the data structure of the return value is different. It wasn't good that way either, honestly, but whatever. It's worse. It's worse this way. All right. Okay, so second base case. We're gonna go else if, and then the scene states, and let's see if we have some more information. So it was array, and we had the set here. So it shows set a few times in this one, right? So set here for a generic type like set. Here we go. Here it is. All right, awesome. Love it. Okay, so it's going to be scene states there it is, dot includes and we'll put the tuple. So the tuple is usually like this, I guess. So we'll put vol A, vol B. Okay. And then in that case, we say loop found. Impossible to finish. And then we raise the argument. Raise argument error new. Okay. So that's that base case. Okay, so now we go to the recursive cases. Okay, so I'm gonna get rid of this down to here. All right, recursive cases. This is where the real action happens. Okay, so this will be else if vol A greater than 0 and vol B less than cap B, self cap B. If self cap B minus vol B greater than vol A, for all of A into B, and that will be self for fill dump, and we pass in 0, vol B plus vol A. Scene states add vol A, vol B, moves +1. And that's it. Okay. That's not too shabby, I guess. I mean, I don't know. All right. So then here we'll say else for A into B until A is empty. So that's self for fill dump. So this time we put volume A minus self cap B minus vol B. And then vol B becomes self cap B. C states add vol A, vol B. Oops, +1. Ooh, man. The scene's, yeah, it is really wet. These would be good ones to refactor. Like, if I get caught up, I still want to look at, like, what time is Advent of Code starting. I don't know how that's going to be. Since I've mentioned it, let me bring it up right now. Advent of Code. They probably, do they have, like, a countdown or something? It might have started already, I don't know. Oh, wow. There's not much time on the countdown. I'm going to be hopefully asleep right around that time. But I'll do it in the morning. That'll be great. So, yeah, I'm not trying to stay up too much longer. And then there's another one called Advent of Cyber, which I'm guessing might be synced up. But somebody mentioned it on one of the Discords, and I was like, I'd give it a shot. I have no idea what to expect from this one, or from Advent of Code, really. Okay, so this one starts later, I guess. This is the countdown, right? It's a purple Grinch? Whoa. This site looks pretty crazy. I like that, I think. What? Huh. Sure, I like that. That site looks wild. All right. Anyway, so those will be for tomorrow. Yeah, this, like, it just needs refactoring like crazy. Okay. Well, that being said, let's do the next case here. So this will be else if. No, this should be end. This should be else if. And it will be vol B equals self cap B. And so now dump V out. And so then this will be self for fill dump. And so now volume A is unchanged. Volume B becomes 0. We still add. Okay. And that brings us to our last state. So for this one, we will fill A to capacity. That would be self for fill dump. So volume A now becomes self cap A. We don't change vol B this time. No. Why do I have a dot there? My gosh. Okay, let's see what the compiler says. Oh gosh. Okay, space required before colon. Okay, fair enough. Fair enough, baby. Unexpected token. Hmm. Is that better? I guess so. Undefined constant 1. So I think for that, it's part of bucket, so wherever we have 1, it might need to be bucket dot 1. And likewise for 2. Let's see what it says now. So that wasn't it, it was just a guess. Okay, so enum. Did I think it was supposed to be here? So color. They do colon colon, it looks like. Okay, that's fair enough. Okay. Okay, so here is where it gets a little interesting. Because I did try to define goal. Oh, wait a minute, wait a minute. Oh, so I haven't finished this part yet. That being said, I think these defs didn't work out quite right. What did the message say? Undefined method goal equals. Oh, so that's a setter. So where would that be at? Getter and setter. Okay, so property age, getter, and we need a setter, it looks like. Okay, so I guess this is what we want. Property, oh, and that gives us a setter and a getter, I guess? Let's try it that way. So instead of this, we'll say property hook cap A, right? Cap B, goal, start bucket. Undefined method goal for 2-bucket module. So I do wonder if it's allowed in a module. Okay, so it said class person. What about in a module? What if I just called it a class instead of a module? Would that be crazy? Huh. Okay, so I'm gonna try putting them down, or putting them right under here. I'm gonna try to add the type, what do they call it? A type declaration? Okay. Okay, so we need an initialize method. And that is... Okay. Darn. Okay, so we don't want... So let's do it with the at instead of the self. Let's see if that's better. I don't know about that one. Okay, let's see. Instant vars are not yet allowed in meta classes. Use at class vars instead. Alright, I'll see. Where was the thing about the property? Class setter. So we don't want property like this. We want class property. I think. Not nillable, so it must have an initializer. Okay. So maybe we don't need this. So we can say equals 0, equals 0, equals 0, equals 1. Very interesting programming language syntax. Okay, cool. So something happened now. Did we get further? So we passed back nil somewhere. Okay, so let's use explicit return everywhere. So if we want to be returning something, in fact, everywhere we have result new, we probably want to be returning, right? Okay, still nil. That's not good. And I'm concerned that changing it from a module to a class might very well have screwed that up. I mean, I wouldn't necessarily expect that sort of thing to work. It almost seemed like it might have been working, but at this point, probably not. So we expected a result, we got nil. Oh, let's turn on some of the other specs so that we can see what is going on some places. So pending. 9 examples, 6 failures. Okay, so these are the failures. So which ones were okay? Was this one okay? Okay. Expected argument error, but nothing was raised. Okay, so that's not good. Okay, so, oh, interesting. So it shows 3 passes. All right, so yeah, the big problem here is I didn't think I should be seeing nil. But clearly that's me not understanding something. Okay, so we're in here. I'm going if, and I have return here, right? Oh, like 30 minutes ago I said, oh, I haven't finished this part yet. And I still haven't. Oh, that's crazy. Okay. Okay, so we do want to call the recursive helper. So, yes, we are going to return self.pour_fill dump. This will be initialized to 0. This will be initialized to 0. This will be initialized to a new set with nothing in it. Oh my god. Constructor, a new empty set. And 0. Okay, so then we have to do this. Okay, so I can get rid of this note. I had that note there to remind myself to do it. I probably should have marked it with to do. Okay, so we're going to say at cap A equals bucket 1. At cap B equals bucket 2. All right. And here it's the other way, right? So this becomes bucket 2, and this becomes bucket 1. We can get rid of these, oops, get rid of this reminder and this reminder. All right. I'm gonna submit it because, again, like it needs work like crazy, but I want to finish one more tonight. I've got a little time if I pick something quick. Like the other night, I did that C# one, and it was very quick. Oh, wait a minute. Cyclomatic complexity too high? Well, I must admit, that's not a big surprise. Oh my gosh, there are 58? Oh no. Underscore cased? Okay, well, if it's gonna be like that, let's change some of them. Okay, so wherever we see cap A, I guess it was supposed to be cap A. Okay. Wherever we see cap B, I guess it was supposed to be cap B. Okay. Wherever we see start bucket, that was supposed to be start bucket. Yeah. Wherever we see vol B, did he also said that one? Okay. Wherever we see vol B, it should be like this. Wherever we see vol A, it should be like this. Okay, let's try again. So I didn't address all of them, but there were so many. All right, let's see what he says now. Okay, I'm going to come back to the cyclomatic complexity, I think. So line 19. So, yeah. Scene states. Redundant return on 23. Oh, okay. So I made them all explicit, but I guess we didn't actually want that after all, because it didn't help, and then I changed the other thing finally that did help. Okay, so wherever we have return result, let's just say result. Okay. Sometimes I'm just doing so badly. Probably most of the time, honestly. Okay, so what have we got left? Redundant return on 40, so I missed whatever was on 40. Okay, then the cyclomatic complexity. So I think we can usually address a cyclomatic complexity by sort of extracting a method. I don't know if that's what I want to do right now, but let's see. Let's get rid of that at the end. Okay, so I think maybe bucket 1, bucket 2. Do we need to pass the goal? If it's going to be part of the setup, then yeah, I guess so. No, I don't know. So line 44, cyclomatic complexity too high. I've got 5 minutes. Okay, so let me see if there's a... Sometimes I can finish a quick one. I'd like to just knock something out real quick to have it out of the way. But I don't know if there's anything that, like, this is C# Pig Latin. That one's probably going to be quick, but probably not like 5 minutes quick. That one's not very quick. It's just kind of a lot of stuff in there, honestly. All right, so I am going to what was it that I didn't address still? Excessive trailing new line. Oh my goodness. I'm just gonna mark it. I'm gonna mark this one complete. Okay. Collat's conjecture is a really easy one. That's the one I did in 5 minutes the other day. It probably won't be that much worse than Rust. Rust sort of scares me, like just the borrowed. Oh, this is the first time I've tried the editor, but I don't want it. I want it local. That borrow checker is a meanie. I'm sure it's fine once you just get a little bit accustomed to it. So this one was so quick, obviously, in the C#. So I'm just going to copy the C# version into here. So I just want to get done quick. So it's the CS file into my source lib rust file. Okay, so now I'm going to edit the rust file. So here's what I have. Let's see, what is, I'm gonna take a guess and say, can we use this type of comment? Oh yeah, I thought so. Okay. So to do something, so let's say if n less than 1, then we want, so it says it's an option. So an option, I think, is like a maybe, right? So let's look it up real quick. Rust option. It's either some or none. Okay, and Rust if statement. Okay. And then so then we will loop. Let's just do while. While is an easy one. Please don't talk to me about FizzBuzz right now. There was a FizzBuzz in here. Oh, man. It was one of the earliest ones I finished, and I don't think I'd have to go back and look in my VODs, but it was this one, Raindrops. It's basically a type of FizzBuzz. And my, let's see, my Common Lisp solution was very, very bad. I need to practice doing good things, not bad. Okay, so I'm gonna say while number greater than 1. Okay. But it's not number, it's while n. While n greater than 1. So we'll increment I at the end. And then here, we will say if n mod 2 equals 0, n divide equal 2, else n equals 1 plus n times 3. Okay, so yeah, that's a very brief exercise, isn't it? So test. Okay, expected one of 8 possible tokens. Okay, expected semicolon. Okay, let's put semicolons in here. Let's take the to-do out. Whoops. Okay, compiling. So I have int expected one of 8 possible tokens. So it's, let's see, oh wait. Okay. So I tried to say int, but we don't say that. We use type inference. But I should say that it is mutable. Okay, now what does it say? Could not compile, but we're getting closer. Okay, so unnecessary. Okay, hold on. Not a valid postfix. Use plus equals 1. Okay, fair enough, fair enough. Okay, what was that other one it said? So we need to get rid of the parentheses here. Fair enough, fair enough. What else did it say? I think that's... Okay, so it was like mismatch types, expected option. Okay, so let's look at the option again. So we do sum. Okay, so now cannot assign, so we could make this mutable. So I'll do that. And okay, so both places. Okay, let's wait a minute. We ignored some, so let's go into the tests. So wherever it says ignore, let's not say that. Okay. Let's submit. And what time is it? Yep, I am gonna go to bed as soon as this is marked complete. Okay. There we go, baby. It says unneeded return statement. Well, I'm not going to mess with it right now. Let's mark as complete. Okay, so to briefly review, today was all over the place. I didn't feel much energy, but we did finish some, of course, so that's good. We just did this one in Rust. We did all 3 of these, and that was it, right? So 4. So that's the same as yesterday. That's not too bad. That's not too bad. So this 2 bucket was an interesting one. Was it marked as a medium? It was marked as a medium in all 3 languages, and I did end up with kind of a lot of code, and I did end up with code that desperately needs to be refactored. The puzzle itself is, I guess, pretty easy, but like there's a weird amount of logic because we have to check like which bucket it is. and stuff, and yeah, so real ugly solutions, unfortunately. But um, I'm trying to cruise through the rest of this before the end of the year, right? So knocking out 4 per day is gonna get me through them all by the end of the year. There are so many though. So there's 2 still that are not unlocked yet. And then there are all of these. Like, there are so many that I haven't finished. So before I log off, let's real quick get the count. So how many does it say are completed? 73. Whoa, whoa, whoa. 73? $73 is a lot. I mean, I have been working on it kind of a lot, but whoa, have I completed 73? And then what are the ones that are not completed? So if it's not completed, then what does it have? It just has track icon and not completed. Can you do not contains? Shoot, I don't think you can. I don't remember being able to. Okay, so there's 138 total, 6 more to be added. Got it? Okay, so 73. And then if we do not, 65. And so that will be up to 71 when the remaining 6 are added, but that's cool. So I'm more than halfway done. There are still so many. All right, so I am, you know what? I just reminded myself of something. I wanted to try raiding. So let me see if somebody is online. I'm gonna look at my phone real quick. Because it's a Saturday after all, right? It doesn't feel like a Saturday because I had work all day. All right, let's see. Who's online? Out of following. Okay, let's try. Let's see if one will work. Raid. I'm gonna search for Kiki Impact. I'm just gonna give it a shot. Let's see what happens. I haven't tried this before ever. All right, it's counting down, so I'm getting out of here. So long. Oh, wait, wait, wait. Never mind, I don't think it worked. It was counting down and it got to 0 and then it went back to the start of the countdown. So, you know what? Never mind. I'm just gonna hop off. I'll try it some other day after I read about it. Have a good